Welcome to the third part of the motion series. In this video, we are going to learn about all those factors that affect the time period of a simple pendulum. And also we'll try to find out the time period of the pendulum. So without any further delay, let's soar the sky. Most of you must have heard about the famous Italian thinker, scientist and one of the world's first astronomer, Galileo Galilei. He was the one who has discovered the telescope, and due to which now we can see all those stars, planets which are so far away from our planet Earth. Now one day Galileo Galilei observed a very strange phenomenon. He saw there was this lamp which was fixed hanging from a ceiling. It was moving slowly to and fro, just like I am moving in this swing. It was suspended with the help of an iron string, just like this, and he noticed that the number of times his pulse beat is always constant with one complete oscillation of the lamp. That means by the time the lamp is completing one oscillation, his pulse was beating the same number of times in each and every oscillation. So then he started experimenting with different types of pendulums, and from there he found out that the length of the string of the pendulum from which the bob is suspended is a very important factor in determining the time period of the pendulum. So if you want to know more about the great scientist Galileo Galilei, please comment below. In the last video, we were talking about the time period of the simple pendulum, and I'll just give you a quick recap what the time period of the pendulum is. The time taken by a pendulum to complete one oscillation is called its time period. Now, from the great scientist Galileo Galilei, we came to know that length is a very important factor of finding out the time period of a pendulum. So, what are the other factors that can affect the time that we calculate from the simple pendulum? The first factor that affects the time period of a simple pendulum, as we came to know from Galileo, is the length of the string of the bob. Now, as we know, the simple pendulum is always hanging from a string. There is a bob, a circular thing that hangs from a string. That length of that particular string is the first factor. How is it affecting? If we increase or decrease the length of the string of the bob, accordingly the time will be slower or faster. Second factor is the mass of the bob. Now, if the bob is heavier or if it's lighter, say for example, if the bob is made of iron, it would be heavier compared to the same sized bob which is made of wood. So this difference in the mass will also affect the time period of the simple pendulum, because heavier the bob is, the slower it will move to and fro as compared to the lighter bob. The third factor is the material of the bob. Since mass of the bob is also a factor, so we can very well understand that according to the change in mass, the material of the bob will also be another factor that can affect the time period. The last but not the least is the acceleration due to gravity. In certain places we know that the gravitational pull is a bit different. So whatever time period a pendulum will show in Earth, that will be absolutely different to that outside Earth. If we take the pendulum and try to calculate its time period into any other celestial body like the moon or any other planet, as the gravitational pull is different in those places, the time period will also be different. So far, if this video has been helpful to you, please go ahead and subscribe to our channel. This really encourages us to create more such informative videos. So how do we calculate the time period then? As we know now all the factors that are affecting the time period, let's come back how to calculate that. The time period of a simple pendulum has this particular formula. It's 2 pi. Pi means a constant whose value is 22 by 7 or 3.14. You can take any of the values. So 2 pi root over of the length of the string divided by the gravitational force. So the formula for finding out the time period is T is equal to 2 pi root over of L by G. So my dear students, if you want me to make a separate video based on the numericals of simple pendulum, please let me know in the comment section. Now let's talk about a very interesting thing. Now in day-to-day life, we always come across different processes, phenomenon, which involves not one but more than one types of motions in it. Say for example, as we were just talking about the pendulum itself, the movement of the motion of the pendulum itself contains 2 or 3 types of motion. It's moving along a same perfect time, within a same perfect time, that makes it a periodic motion. It is oscillating to and fro, so that makes it an oscillatory motion as well. So there are many other examples that helps us to know that one particular process or phenomenon can contain not one type but more than one types of motion in it. Over here, as you can see in the game of cricket, the ball is released by the bowler in forward direction, and as soon as the ball strikes the bat of the batsman, its direction is changed. So at first it is showing translational motion and then its motion is changed into rotational motion. For example, the cycle is moving forward, exhibiting translational motion while its wheels are rotating along a fixed axis, making it a rotational and circular motion. Thank you for watching this entire video. In the next video, we are going to learn about the scalar and the vector quantities. So, see you in the next video.